Hi, I would like to welcome you to today's tutorial. We are going to talk about the numerical control programming, and we are going to introduce the machine code programs, what we call the G&M codes. So this is an example of it's quite short code for doing the profile cutting for the shape you can have in front of you. So you can see that we have a codes consists of the G05, M03, then we had the G0, we had the G1, the X, the G3, the G2, and extra. So we're going to explain what the meaning of this one, but if you can just make a comparison of what we have on the code and what we have on the diagram, you'll make a full idea of what's going on. So first, we have the first position. We're moving. If I'm going to move clockwise, we have to move to the second position, move to that position, and so on. And we're going to change between what we call the linear interpolation and the circular interpolations. So the creating of the numerical control part of the program, we can use the manual code writing as we said in the lecture. And this would visualize the machine operations from the drawing of the part and write the machine dependent instructions by using the G&M codes. We can do the computer assisted programming, and this will be a higher level language by using the APT or the except, and is going to be compiled into the cutter location file, the CL file, and the CL file is going to be post-processed into the machine code, which generate the G&M instruction by using the computer software. And also we can do the CAD/CAM, and that's what we're going to learn next week, is how we can make a 3D geometry for the part. Then we can use the model going to be used to create the tool path graphically, and then we can generate the CL data program by using the CAM, and then we can transfer it by the post-processor software to generate the G&M codes and export it to the machine. So for the manual numerical control programming, and that's what we have to do in this assignment, we have to learn about the simple codes, which call the G&M codes or the machine codes. We have to run the part program to create the components or the part to the machine, and we have to we are going to have lines of the codes, which each comprising one block or line, and each going to be representing the next location of the tool center points along the tool path. The line of codes begin with the block number n, and this will define the number of this line or the number of this block. Then it's going to be followed by a G code indicating the geometric motion of the tool, or an M code which representing the machine functions such as the turning of the spindle on or off, or even for the cooling the fluid or the lubricant. We have to define the feed rate, which is going to be shown by using the F code. You remember what the feed rate is: the linear motion of the table in the milling machine, for example, or the linear motion of the cutting tool in the case of the turning process. Most of the G codes are going to be followed immediately by the X, Y, and the Z values for the location of the tip of the cutting tool to show the next physical position of the tool center. The programming can be done manually by the part programmer, who is going to be you in this assignment, or we can do it via the CAD/CAM software like the SolidWorks, SolidCAM, the Creo, or the Autodesk. And that's what we are going to learn by next week. The standard G codes and the M codes we have are, so these are the main thing we are going to use. Like the G90, which is going to set the absolute coordinates, we can use the G91 to set the incremental coordinates, and that's what we described in the lecture, difference between both. So the absolute coordinates, that's all the points going to be identified as the location of the X, Y, and the Z from the datum point or the 000 point, or the G91, which what you call point-to-point movement. That means that the next location will be defined by its distance from the recent location. The G00, that means we are going to have rapid move for the cutting tool, and usually it's going to be straight line movement but without doing any cutting. G01 is going to be a straight line move at the set of the feed rate. That means we are going to perform some cutting in the cutting tool. The G02 and G03 is going to be the circular arc movement, either clockwise for the G02 or counterclockwise for the G03. The M03 is going to be start the spindle rotation, and this usually is going to be counterclockwise. The M00 is going to be the end of the program and stop the spindle, and then we have to repeat the program once again. Other G and M codes are different for each machine control combinations, and even the above codes can be vary among different machines and controllers. The program line, we said that each line of the program has standard form of with variation according to the particular motion required for the tool, or specifically we are going to define what will be the path of the center point of this tool, and corresponding machine codes are going to be used. And this is an example of the program line we are going to have, or what we call the block. So as you can see here, that the first thing is going to be the N, which define what the block or what the sequence number is. This one is N15. Usually the numbering of the line is going to be as N1, and then we can start with the N5, N10, N15, N20. We keep 4 lines as a space because simply we can follow this one by N16, N17 till N19. That's in case if we would like to add something between the blocks. The G90, that's mean we are going to use the absolute coordinates. G00, that will be the rabbit feed for the movement, the movement to the next location. And the X, Y, and the Z are going to define what will be the location of the next step or next position of the tool. F100, that's the one with the feed rate in millimeter per minute. This is another example. Now, obviously for this one we are using the G03. That means we are going to have circular interpolation. Because it's 03, that means it's going to be counterclockwise. And you can see that the X, Y, and the Z, well, that's not here because we're doing the interpolation in 2 dimensions. So you can see that we have the X and Y, which is going to be the absolute coordinates of the next position of the arc, where the cutting tool is going to move to. The I-10 and the J2 are going to be the center of the arc from the last position of the tool. The center of the arc from the last position of the tool. So it's going to be 10 in the X direction and 2 in the Y direction. The most important thing for any programming is to set the 0 or the datum point. And even when you are going to use the CAD-CAM, you have to set your datum point. The definition of the program 0 or the datum point is a point on the job, or sometime on the stock material. Usually we are going to have it on the stock material, and it's going to be chosen by the party programmer, and to which all the coordinates are going to be referred. The origin of the coordinate system is going to be the 000 point. Okay, so once again, the program 0 or the datum point is the point on the job or sometime on the stock material. That means, for example, if I'm going to have the stock material height is, let's say, is going to be 10 millimeter higher than the final surface we're going to have. That means that my point is going to be 10 millimeter higher than the surface I'm working on the drawing. It's going to be chosen by the party programmer, and all the coordinates are going to refer to. So it's going to be the origin of the coordinate system, and all the X, Y, and the Z value is going to be set to 0 at this point. Its location cannot be included in the program, that's mean in the G and M code, but usually we can identify this point when we do the CAD-CAM. Its location has to be communicated to the machine operator using the drawing of the part and of the blank as is going to be appears before any machining. Okay, so for the ease of the setting up and checking that the program does not send the tool into the machine table, The program 0 is often going to be sent for the milling to be at the top surface at the bottom left hand corner of the finished job. So if we are going to talk about, we're looking for the top view of the work part, this is my screen, this will be the location, this one at the top surface at the bottom left corner, if you can see my mouse. Okay, so that will be the recommended location we are going to have it on the top surface left bottom corner. But still we can have it at any point, then we have to change our coordination to. But usually if we are going to talk about any programming, this will be the positive y-axis, positive x-axis, and the positive z-axis. So if you are going to be here, that everything will go here will be negative y-axis, negative x-axis, and so on. So that's the best location I'm going to talk about. The blue line is going to show you what the stock material is from the top, and this will be my datum point for the positive y and positive x, and positive z is going to be the arrow toward us. So you remember that for the milling machine, that the spindle rotation axis is going to be the z-axis. Positively one is going to go up, actually the table will go up, and the longest side of the table is going to be the x-axis, and the other left axis is going to be the y-axis. That's for the vertical milling machine. If we are going to have horizontal milling machine, now once again the axis where we are going to have the rotation to happen is going to be the z-axis. The longest side of the table is going to be the x-axis, and the other one is going to be the y-axis. Okay, so that's what we talked about earlier. So these directions are set so that the motion of the tool relative to the table is called the positive one is going to move to the positive x-axis, y-axis, or the z direction. Other direction is going to be negative values. Okay, know that in actual fact it may be the table has that's moving while the tool is going to be stationary, and that's what's happening most of the time. The absolute dimensioning, as we mentioned earlier, we're going to have a datum point, then we're going to define all the positions with reference to this point. So this is the x-axis. My x-axis value is 1 inch for the center of these points, and the y value from the center for number 1 is 1.25, 2.75 for number 2, 4.25 for number 3, and 5.87 for number 4. Okay, so each position of the tool is going to be specified by giving its x, y, z coordinates with respect of the program 0 point. When the absolute coordinates are going to be used in the x, y, z value are always going to be relative to the 0 position. And that's what we're going to have in the coding. Usually we're going to apply the G90 at the beginning to define that we are going to use the absolute dimensioning. Then, as you can see here, that at the beginning, for example, we apply the value for the for the y and the x, but later we just change the value of the y, because what happened is that we don't change the value of the x, and because we're using the absolute dimensioning, that means we're only going to change the value of the y with reference to the 0 point. The other type is the incremental chain dimensioning, and in this case you can see that the distance between the points actually is going to be reference to the previous point. So 1 to the datum is going to be 1 and 1.25 for the 1.25 and 1 for the x, 1.25 for the y. Then the next point is going to be referenced from the last position, so we're only going to move y of 1.5. Then third one from the 2 is going to be 1.5, and the fourth is going to be from the third by 1.62. The code we're using in this case, in the case of the incremental, is going to be G91, as you can see here. The other system we have is the polar coordinates, and this usually is going to be used when you are going to have a drilling like this one. So in some situation more convenient to specify the next position of the tool in terms of the polar coordinates rather than its x, y, and z coordinates. Not all the machines having these features, just a specialized machine can do this one. The control statement, which do not involve of any tool movement, but is going to set up the certain parameters needed in the machining operations. For example, we don't do cutting, but we are going to define that the spindle should be start. So to set the spindle on is going to be the M03. The F200, for example, to set the feed rate to 200 millimeter per minute. The G05, for example, is going to pause the pause or dual for a given time, and G25, that's going to be subroutine, should be called. For the other type, the geometry of the proprietary statements, which what we call the G codes, like the G00, the G01, the G02, and G03, are all model and need to be repeated in consecutive blocks. Most of the geometry codes require coordinates, and criterion is going to be X, Y, Z form, and in the same block indicate the next position of the tool. So if I are going to set the value for the X, Y, Z in the line number 1, that means we are going to go to the position number 2. The machine or the miscellaneous statements, what we call the M code, once again, like the coolant on and off. So it's not control statement, it's not geometry or property statements. It's going to be a miscellaneous statement like turn on or turn off the coolant fluid. Start the spindle in counterclockwise direction, the M03, and stop the program and set the program from the beginning to put M00. That's mean if I'm going to do the next cut with the same program, I'm going to add the M003 at the M00 at the end, and that means that the program is going to be repeated once again. For the linear interpolation process, or what we call the linear motion, I would like to have a straight cut on the work part. So this is an example. We have 2 points from the origin. The first one is going to be X30 and Y15, and the second one is going to be the X80 and the Y60. And I would like to make a straight cut between them. So first, the line number 0 is start the spindle. Without starting the spindle, your program is wrong. Now you can see that the depth is equal to 5 millimeter beneath the Z point, the datum point. So the first line is just define that you are going to use the absolute coordinations, and then we are going to take the cutting tool in linear motion without doing any cutting to the first point, center point, but is going to be at the height of 5 millimeters. So we drove the cutting tool from any location in this space to the location at the top of the first position. X is equal to 30, Y is equal to 15, and Z is equal to 5. Second line, I would like to do the cut, but this one is going to be something similar to the drilling process. So I have to say that I'm going to do the linear interpolation with cutting. So it's going to be G01. I'm not going to move in the X direction or the Y direction. The only direction I'm going to move to is going to be the Z direction. So I set the Z value is going to be equal to -5. That's means my cutting tool end point in the center is going to penetrate the metal or the part by 5 millimeter below the datum point. That's why I put here -5. The feed rate is going to be 100 millimeter per minute. Now I would like to move from this point to that point, and in my way I'm going to cut a groove, straight line. So G01 no need to be repeated because it's going to be used here. So you can see it's not going to be changed until I'm going to define otherwise. The only thing I'm going to move to is I'm going to move from this location, which was actually the x30, y15, and the z is equal to -5, to the x80, y60, z is still -5, and the f is going to be 120 millimeter per minute. So I reached this point, I cut this straight groove in my way. Then I have to take the cutting tool above the surface so I will be able to remove the part. So I will go in rapid movement to G00, that's my rapid movement, upward, where the Z is going to be equal to 50 millimeters, and then I have to stop the spindle, start the program from the beginning. Well, taking it to the height of 50 millimeter will enable me to remove the vise, for example, and then I have to take the part off, put another stock, and repeat the operation. The other process we can do with the G coding is what we call the circular interpolations or the circular motion. The old method that it was used is using what we know it as the IJ code. Now nobody using the IJ code, but still have some advantages above the radius code, the R code. Now we're going to discuss about this one soon. So I would like to make a linear interpolations to make the horseshoe shape. With the central radius is going to be 25. Now the outer radius and the inner radius is going to depend on my cutting tool diameter. Okay, so you can see that always we're going to have that the tool path is going to be offsetted from the cutted path by the value of the radius of the cutting tool. Now once again, start the motor on G01 to the position of the first of the top point, which is going to be the x is equal to 40, y is equal to 60, but is going to be at the height of 5 millimeters. Then I'm going to penetrate the cutting tool inside the work part to the depth of -10 millimeters with the feed rate of 100 millimeter per minute. Then I will start to do the circular interpolation G02. That means we're going to have the cut on the clockwise direction. So I will identify what will be next position of the cutting tool. So it's going to be x equal to 15, as you can see here. X is 15, while the y is going to be 35, and the radius with this movement is going to be 25 millimeter. Okay, now the other way I can do it is use what we call the INJ code, and this will define what will be the position we are going to have for the center and what will be the radius we are going to have for the cutting tool. So this will be the Y location, and this will be 35, and for the X location is going to be 40. Okay, so we define the center while we're moving from the recent point to the next point. So actually the program and the machine processor will do the calculation for the radius value. Well, in the R25 you give the value of the radius you would like to have. Then we reach this point, we have to leave the part and take the cutting tool out, and that's what we are going to use as G0. The Z is equal to 50. Then we take the X and the Y to the datum point where the X is equal to 0, Y is equal to 0 at the height of 50 millimeters. Then stop the program and go with the reader to the beginning. So absolute and incremental programming, well, we talked about this one. I don't have to go through this one by details, but as we said earlier, if I would like to do the absolute cutting, I have to use the G90, and in the case of the incremental one, I'm going to use the G91. This will be very useful in case we are going to do the multiple drilling process. Okay, that's another example for the thing. Okay, so you can read this one when you have the time to do that. I will go to the other one, which is the radius compensation. Okay. Okay, now I'll try to go to the useful thing for you later. Okay, example in the machine code on the router. Okay, the tool compensation is very important, which is going to be the tool length compensation and the radius compensation. In the manual programming, the length of the tool, in the case of the drilling and the tapping and extra, or the radius of the cutter in the milling contours and the pockets must be taken into account when the programming of the geometrical dimensions of the job to be done. Note that in the CAD/CAM method generating of the contour tool path, for example, the tool compensation is going to be automatically accounted for the cutting and the actual offset of the radius tool center path is going to be generated by the CAM program, and it's going to be provided by the tool dimension are going to be supplied to the CAM system. If we don't do the CAD/CAM, we have to do this compensation manually. The cycle statement, which is certain operation on the milling machine in general, requires a series of the steps to achieve the required results. For example, I have to do the drill deep hole requires several plunging steps. The depth of each step depends on the total depth of the hole I'm going to have, and the dowel at the bottom of each step, and the milling of the pocket requires a number of the passes to remove the material. Because for this operation are called the cycle statements or the CAN cycle, and the CAM system create the required CAN cycles automatically. Some more details for the example. Okay, so for example, this is a simple CNC program. I have the percentage value, then I'm going to have 2 points and the figure, which consists of 4 digits. Then I start the line number 5, 10, 15, and so on till 55. First I have the G90, G20. Okay, G90, this will define that we are going to use the absolute system. G20, that means I'm going to use the inch system, the empirical value, not the SI value, not the metric value. Actually, all the machines we have all around the world are using the metric value, the millimeters value, except if we are going to define it as G20. In the United States, they have the other way around. So all the machines are set by default to the inch value, and if you would like to change it to millimeters, you have to put the G21. Line number 2, M06 T3. Now we have a new value for the M6 and we have the T3. N15 is going to be the M03, the S1250. The N20 GOO, where the X is equal to 1 and the Y is equal to 1. Obviously this will be in inches. The N25, go to the Z is equal to 0.1. The line number 30, the G01, that's mean we're going to do some work. Penetrate the cutting tool to the height of minus 0.125 with the feed rate of 5 inches per minute. And we continue the process. So the letters A to Z is going to be used to designate the functions, and the number 1 to 99 used to designate the location of the meaning function. So to define that, what are the major phases of the CNC programming? First, as we said, that the percentage value, that means we have the program start flag. The 4-digit program number is represented by this figure. Absolute unit and the inches, the G90 and G20. M06, that means we are going to stop the tool for change the cutting tool, and then we're going to use the tool number 3. So T is for the tool number. We need to change the tool from time to time. Of course, if we're going to have the machine which can do multiple spindle head. And the M03 with the S100 125, as we said earlier, that the M03, that means we have to turn the spindle in the well, actually this one's counterclockwise with the S value, which is the spindle speed, to 1250 RPM. the G00 is rubbed to the next position from the origin point. The Z01 gets me rubbed down from any height to the height of the value of 0.125 inches. Then we are going to do the free feed down to the depth of the Z equal to minus 0.125 from the surface at 5 inches per minute. Then we are going to move by feed diagonally to the next position, 0.2, where the x2 and y2 values. Then we are going to have to go up rapidly to the Z1 value of the Z of 1 inch. And then we have to go back to the origin where the x is equal to 0 and y equal to 0. M05, turn the spindle off, and the M03 is the end of the program. So now the white lines are going to define a phase number 1, which is the system setup. So you define what the program number, what the unit you are going to use, coordination unit you are going to use, and what the unit you are going to use. You are going to stop the spindle, change the tool, and then you're going to turn the spindle with the amount of the RPM you are going to set. The second phase is going to be the material removal phase, and this highlighted with the red one. So all the movement we did with certain feed value is going to cause a material removal, and this will be the phase number 2. After we did all the cutting, we have to have the phase number 3, which is the system shutdown, like the turn of the spindle and end of the program. So something like when you write down a letter, you have to have an introduction at the beginning, the content, and the conclusion. So for the program start flag and the program identification number, the percentage is going to be the flag start program start flag, which is placed at the beginning of each program. It's not going to be read by the computer. The 4-digit number is the program identification number. Each program will have its own column number. Actually, this can be used if you are going to store multiple programs in the CNC machine, so you don't have to write down the program every time. It's going to be stored there with a unique identification number. So each time you would like to use this program, you just call it and then you can start it. These are the only 2 commands that don't start with letter. Doesn't have line number and doesn't have any code with it. The difference machining, the controllers have different start flags and program numbers. For the encodes, it's giving an identification number of the for each block of informations, and is generally going to be good practice to increment each block number by 5 or 10 to allow the additional blocks to be inserted, and the future changes are required. For the R and the P codes, and this one is different from the radius code for the R. So the R code, which is the retract distance one, is going to be used with the G81 and G82 and the G83. The radius is going to be used if I'm going to use the G02 and the G03. The P code is going to use to specify the dwell time associated with the G04 code. So this is a list of all the codes possible, and actually between all these codes we are only going to use something about 7 to 8 of them. And obviously it's going to be the G00 till G03. That's for the linear translation and for rubber traverse. And we're not going to use this one, not this one. Compensation, cancel, left, full circle. I'm not going to use this one. Absolute dimensioning and the incremental dimensioning. Program stop, program spindle on clockwise, the spindle on counterclockwise, the spindle to stop, the tool to be changed, the coolant on, coolant off, the clamps on, clamps off. You have it, the automatic one, and the M30, which is the program stop and reset to the start. So the X, Y, and Z codes are used to specify the coordinates axis values, and the number following the codes is going to define the coordinates at the end of the move relative to the incremental or the absolute reference points. The number may require that specific format to be used. For example, 3.4 means it's going to be 3 numbers before the decimal and 4 numbers after the decimal. The I, J, and K codes are going to be used to specify the coordinates axis when defining the center of an arc or a circle. But only 2 of 3 are going to be used at the time, depending on which the plane are going to be, the circle is going to be on. So I and J is going to be for the XY plane, and this will define the value for the X and the Y on the plane. I'm going to use the I and the K if I'm going to use the X and Z plane and respectively. So obviously you're going to have the J and the K if I'm going to have the Y and the Z plane. The number following the code defines the respective coordinates of the center of the arc. The number may require that specific format to be used. For example, the 4.3 means 4 numbers before the decimal and 3 numbers after the decimal. Many of the machines allow the arc code now to be used to define the radius of the arc instead of using the I and J codes, which is define the center of the arc. Now, the disadvantage of the arc code is the programming of 360 arc. The arc code can only cut up to 359 degree, but it cannot complete the 360 degree. Well, don't ask me why, but that's what's happened. So 360 degree arc are most easily programmed by omitting the destination point and specifying only the plane, direction, and the appropriate I and J value or K codes for the center of the arc relative to the start point. So simply I can write down the code of G03, G17, the I is going to be 15 and J is going to be 0. So I identify what will be the center point while I'm going to do the movement in counterclockwise. Once again, the plane of the arc does not need to be programmed if the machine is going to be already set to the correct plane. It's important with all the arcs that the end point of the arc and the radius of the arc are going to be calculated correctly to prevent the machining error. That's some of the example for the I, J, and K and R codes. Actually, G02, this means clockwise command, requires the endpoint and the radius in the outer in order to cut the arc. For the I, J, and K are going to relative to the start point in this example if the G91 is going to be used. For example, if I would like to use the I and J code, so simply I'm going to write down that GO, that means do the arc cutting in clockwise direction, where the X is going to be equal to 2 and Y is going to be equal to 1, which is the red point you have here. So we only define what will be the end point we are going to have, and then we are going to define that the for the center the I is going to be equal to 0 and the J is going to be equal to -1. Now, why we use the I is equal to 0 and the J is equal to -1? If my start point is 1 and 2, sorry, so from this point we have to go at the same value for the X. It's not going to be changed, and the Y value is going to be incrementally -1 from the origin point. So this will be my center point, and I'm going to have this cutted arc. Now, if I would like to say it in the arc code, I'm only going to define that the radius is equal to 1 inch. Then I'm going to have the same cut. So one of the example, actually I think this was the assignment for last year as well. We would like to do a program to do the following cutting on 3-axis milling machine. So this one is saying the use of the G code and the M code to achieve the finishing cut only. That's mean we did all the cutting, we had this final shape, and what left is 1 millimeter on the side to be removed. That means that my cutting path is not the my cutting path is going to be offset from the final length I'm going to have, because in the way is going to cut 1 millimeter off from this circumference to have the final dimensioning. Now, to analyze this job, we need to consider the machine we are going to have. We have to determine this program 0 point. We have to find out how many steps we should have, and find out what the kinds of the tool we should use, and then begin to program the code. So we are going to use these codes: G0, G01, G02, G03, G05, M03, and the M02. So for example, and that's what we are going to do actually in your work. In the assignment you have to do multiple cuts. You have to do the face milling, for example. You have to do the pocketing in the middle, and you have to do the drilling, and you have to do the profiling at the end. Now in your case, you only have once again to remove 1 millimeter from the side to get the final shape for the profiling, but still you have to do all the cuts to shape the top level, because actually it's very easy operation. I'm going to give you an example for that. So you can choose the cutting tool diameter, and let's say it's going to be 10 millimeter diameter. The speed of the feed should suit the piece work and the tool, because you know that we have different cutting tools. Each one have a certain value for the feed rate. Depend on what will be the cutting tool material. It's going to be carbide insert, or it's going to be high speed steel. Use the backing of the material for a certain thickness to allow a proper clamping and the machining periphery on the job. And then we can use the T-nuts and the bolts for the clamping the part to the machine table. The program 0 is always going to be at the top surface at the bottom left hand corner of the job. The roughing machine has left 1 millimeter, as we said, all around the periphery for the finishing operation. So the yellow one is the original stock material. We have removed most of the material. The only left is 1 millimeter above these dimensions, and that's what we have to remove. Analyze the work. We have 7 fillets rounds of our 15 millimeters, and we have 7 lines. Okay, so if I get to count that, the fillets are 1, 2, 3, 4, 5, and the lines are going to be the 1, 2, 3, 4, 5, 6, and 7, and we have the holes as well. So the blue line is going to be the tool path. The black line is going to be the cutting path. They both offset by the value which is equal to the radius of the cutting tool. Now to do the programming, first you have to decide where we're going to start from. Okay. Now for example, this position will be the first position. It should be offset for the X direction and the Y direction. As you can see, it's going to be in the negative X-axis and negative Y-axis by the value of the radiuses for the cutting tool. So if the radius of this cutting tool is going to be, let's say, 5 millimeters, that means that the first position we're going to have here is going to be Y is equal to X is equal to minus 5, Y is equal to minus 5. Then we are going to go to define the first point. That means I have to go with doing some feed cutting. That means G01 to the next point dimensions, and in this case the Y is not going to be changed, the X value is going to be changed. So G01 where the x is equal to the distance from this point to that point. If this one is 245, that's mean to move from this point to that point, I'm going to add the radius, which is 5, plus 245 to this point. Let's make it 250, plus 5 to the next position is going to be where the x is equal to 255. Then we have to define this point center. Once again, is going to be G01 with a certain feet rate. Then I have to make a turn to make a circular interpolation, and this one is going to be counterclockwise. That means I have to go with the G03, and I have to identify what will be the center point here. So the center point here is going to be, obviously, I have to know what the radius of this arc is, 15. That means it's going to be 7.5 onward. So we have 245 minus the 7.5 to reach this point in the location of the x-axis. For the y-axis is going to be 25 plus the 40. Now, if I would like to know what the center point for this one, I can find that the x value is going to be 245 minus 15, which is the radius we are going to have here for this arc, and for the height is going to be 80 plus 7.5 millimeters, and so on. So let's see what the program is going to be at the end. My advice, if you would like to know how to do the profile cutting for your work, you have to compare what we have here as a value for the code or the diagram we are going to have. Okay, this was another example. I moved this one. Okay, this is another example on how to do the grooving if we are going to have a certain depth. Okay, I'll leave this one for a while because I would like to show you a live example on how to do a cut similar to the one you have on your assignment. First, I'm going to show you this part on the SolidWorks. Actually, this is the part I made for your example. It's going to be just a shape. If we take a look from the top, we have 2 holes and 1 pocket hole, and we are going to have 1, 2, 3, 4, 5 lines, and we have 1 circular side. So just 1 fillet on the side, and the radius something about 40 millimeters. And for these fillets, it's something about 10 millimeter radius. Now, to check the engineering drawing for this one, that's what we're going to have. Okay, now I would like to do the cutting for this shape. Now once again, I'm going to consider the same process. I have the stock, I have 1 millimeter left from each side before we finishing this work. Now in the matter that we have something called the rough cutting, and we have the finish cutting, and what we're going to talk about now is the finish cutting for the profiling cutting. So I'm going to choose a cutting tool. It's going to be a circle cutting tool with any diameter I will choose. Now consider that this one is going to be 10 millimeter diameters. This will be my first position. Copy. This will be my second position. This will be my third position. Fourth position. Okay, this one should go to this position, and this is a tricky one because my cutting should be on this direction. and I have to leave the area completely before going down. Okay, so it's not going to be here because in this cut we are going to remove this edge. So we have to go when we're going to have a tangent with this work. Okay, so this will be my next cut. Okay, and then we have to go down. Now this is for the profiling, but the trick is how we are going to hold the part. This is a very important issue. So it's much better to divide the work, the programming, into phases or setups. So if I'm going to have a block, just rectangular block, and I would like to do the cutting on it, I have to hold it before I get to do the work. Now the most common thing, if I'm going to have small dimensions like this one, where the well, actually the longest length is going to be 200 millimeters, and the furthest height is going to be something about 50, I think it's going to be 100 millimeters. So the best thing is to hold it with the vise. If I'm going to hold this part with the vise, I will not be able to do the profile cutting. Even if I'm going to use the clamp, I will not be able to do the profile cutting, simply because that the cutting tool is going to be cutting the device or cutting the clamp device. So the best thing is, because this part does have holes, is to drill the holes, remove the vise, and then we're going to use bolt and nuts to fix the part into the milling table. So we have these sides. We're not going to use the blue one first. We're going to use the, what is it? Okay. I'm going to make it as the orange one. So first I can hold it with the vise. Holding the things on the vise, that means it's going to be higher than the table, and the table will be safe while I'm going to do the drilling operation or the hollow pocketing operation. So the pocket here is going to be cut with the same cutting tool. The cutting tool I'm going to use for this one, if the diameter is 15 millimeters, then I'm going to use the cutting tool, which is going to be 15 millimeters. The first step I'm going to take is bring the cutting tool from any position. Define that the next position is going to be the following: G00 to this position, where the X is going to be 20, the Y is going to be 20, and the Z is going to be, let's say, 5. If I'm not going to reach this point, do the drilling. That means I'm going to go with the G01 equal to what the thickness of the material, let's say, is going to be 20 millimeters. Do the drilling. Then G00 to Z equal to 5 once again. Then move to the next hole by defining what will be the X and the Y value and using the G00 code. Now I'm here. I can't fix it in the middle. Anyway, now when I'm here, once again, G00, where the value of the X is going to be 200 minus 20, 180, and the Y is equal to 80. Then go with the Z, G01, with the Z is equal to minus 20, and the F value is equal to 120, for example. And then go to G00 up to the level of the R, the Z is equal to 5. I finish this one, I have to come to here now. I'll go to any point. Let's say I'm going to do the drilling here. Okay, so if your cutting tool is going to have 20 millimeter diameter, that I don't need to do any circular interpolation. But for example, if it's going to be 5 millimeter radius, then I have to do the point to point movement to do this pocketing process. So the movement is going to be from here to here, circular interpolation, linear interpolation, circular interpolation, linear interpolation, circular interpolation, linear, circular, and go back to the same position. I don't have to remove the material in the middle because simply I cut everything around, so it will fall down automatically. So I did this cutting. I will remove the vise. I'm going to use the bolts and the nuts. I have to put a pad below that with the thickness, let's say, of 5 millimeter to protect the table while I'm going to do the profile cutting. Okay, now I fix the part, and I know what the value of the datum point, which is this point. This will be my datum point. Let's have an arrow there. Okay, so that's my datum point, and from there I'm going to make a sketch to do the cut. So this will be my first line. Okay, then I'm going to have an arc. To be honest, I don't know how to sketch the arc in the PowerPoint. This will be next movement. Next movement. Then go back to the point I started with. I think okay, so that's what we're going to have for the arc here. Now what we have to put in consideration is that we're always going to keep a distance. It's too tricky. Okay, so we always have to maintain the offset between the tool path, the yellow line, and the cutting path, which is the black line here. Okay, now this offset should be equal to the radius of my cutting tool. Okay, the radius of my cutting tool. I don't know why it's changed. So before you are going to start to do the programming, you have to identify the point you are going to move to. And if you can print the same engineering drawing I gave you or part of it, you can use any circular thing. For example, you can use the 5-cent coin and you use it as the diameter of the cutting tool and start to do the programming. So first you have to identify what will be the locations, what will be the center point of these circles. Then you have to identify what will be the value of the G code. It's going to be the G01 like this one, or it's going to be the G03 like this one, or go back to G01, 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 and G01. Okay, so that's most of the important thing we have to know about. Now, in case if you need to do some face milling, for the face milling, you have to remove as much material as possible, or you have to increase what we call the material removing rate, and this will mainly depend on the diameter of the cutting tool. If I would like to remove, for example, 5 millimeter thickness from the top of my work part, that means I have to go where the cutting tool is going to be bigger. because this will make my process faster. Okay, so I start, for example, from here. At the beginning, I'm going to set away the center point of my cutting tool is going to be in the negative direction of the X with the value which equal to the R value, the radius of the cutting tool. So minus R value for the cutting tool. Now just remember that we have to cut with the half of the cutting tool at the beginning. So I'll travel with this one till the end of the work part, go up, redo the cutting, go up, do the cutting, up, do the cutting, and continue doing that until you remove the whole unwanted surface. So the process is going to be first G00, take the cutting tool to this position, and let's say the height is going to be something about Z is equal to 5 millimeters. Then I would like to remove 5 millimeters, so I will take the G01 where the Z is equal to minus 5. That's when the cutting tool went down. Then I start to move it by G01 sorry, to the final point I'm going to define here, where the half of the cutting tool will be outside the work part and the other half will remain in. Then I have to take it up by the height which is equal to the diameter of the cutting tool, stop here, then go back all the way to here. Half of the cutting tool in, the other half is out. Then go with the value of the Y which is equal to the diameter of the cutting tool, go back once again, up, back, until I get to remove the part I would like to remove. Okay, so we covered everything. Just remember that the setups in this case is going to be 3 times. If I would like to do the face milling, I'm going to use the vise to hold the part. Drilling and the pocketing, I'm going to use the vise to hold the part. For the profiling, I have to use the bolts and the nuts in the drilled hole to hold the part while I'm going to do the operation of the profiling. Okay, now this is it for this video, and if you have any question you can send me an email, or we can meet during this week before the due date is going to be Monday. Maybe I'm going to extend for another 3 days, so we can meet. If you have any questions you can ask me and I can clarify it for you. Okay, thank you and good night.